This lecture we will discuss Unit 3, that is solution of algebraic and transcendental equations. An nth degree polynomial is said to be defined as f of x is equal to x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus and so on plus an. It is called as a nth degree polynomial. An algebraic equation of nth degree is with the polynomial is equal to 0 is called as a algebraic equation of nth degree. The examples of algebraic equations are general equations. It is a polynomial is equal to 0, all are algebraic equations. So this is a algebraic equation of degree 1, this is the algebraic equation of degree 2, this is the algebraic equation of degree 7. An equation which is not an algebraic equation is called a transcendental equations. So generally the transcendental equations involves the trigonometric functions or exponential functions or the logarithmic functions. So a value of x which satisfies the equations is called as a root of the equation. The value of the unknown variable which satisfies the given equation is called a solution or a root of the equation. So the following methods we will discuss in this topic to find the root of an algebraic equation and transcendental equations. So the first method is bisection method, the second one is false position method, the third one is the Newton-Raphson method, and fourth one is iteration method. So first we will discuss the bisection method. So before discussing the methods to find the root of an equation, first we will discuss an intermediate value theorem. So generally which states that if f of x is a continuous function, f of x is continuous, and at the point A, so let it be x-axis, this will be y-axis. At a point A, the functional value of f of a is a positive. That means it will take on the positive side of y. This is a positive value. And at a point B, if it is a negative value, then it will take the negative y-axis value. Or let it be a negative value. If it is a continuous function, then the curve will be definitely like this. So since it is a continuous function, it is a continuous curve without any break from the point capital A, from the point A to point B, or it will be like this, okay, or it will be like this. Anyway, it will definitely crosses the point x, the crosses x-axis. So at the point, if it is C, at the point C, the function is equal to 0. So that means if f is a continuous function and the function value is positive at a point and negative at a point, then there exists a point C in between A and B such that f of C is equal to 0. The possible case also, if f is a negative at this point, let it be here, and it is a positive at B, then definitely it crosses the x-axis at a point C. That means this point C is the root of the equation, since f of C is equal to 0 here. Since it touches the x-axis, so that means C is the root of the equation. So understanding this concept, the root of the function is lies in between A and B if f of a and f of b are of opposite sides. That means if it is less than 0, f of b must be greater than 0, or if f of a greater than 0, then f of b must be less than 0. If this is possible, if you have found the two values a and b such that f of a and f of b are of opposite signs, then there exists a point c in between a and b, which is the root of the equation. So our aim is to find the value c which satisfies the given function, that means f of c is equal to 0. So here we are discussing to find the approximate roots. So these methods are not supposed to find the exact root. So that's why we are discussing an approximation roots of the given questions. So the procedure is bisection method. Let the given function be f of x is equal to 0. Find the 2 points a and b with the condition f of a and f of b are of opposite signs. It is f of a less than 0 and f of b greater than 0, or f of a greater than 0 and f of b less than 0, since these two are of opposite signs, in which the function has opposite signs and the root lies in between a and b. So in bisection method, we will find the first approximation as x1 is equal to a plus b by 2. So if f of x1 is equal to 0, then we are done. That means this x1 is the root of the equation. It is x1 is exactly the midpoint of a and b. Otherwise, if f of x1 is less than 0 and f of a greater than 0, then the root lies in between a and x1, and x2 is equal to a plus x1 by 2. If f of x1 is greater than 0 and f of b less than 0, then the root lies in between x1 and a, and x2 is equal to b plus x1 by 2. Continuing in this process, up to 2 successive approximations are equal, and the final approximation value is root of the equation. That means, if you are continuing to find the root of the equation, suppose a and b like this, in which f of a is positive and f of b is negative. So the curve may be like this, but in the bisection method, we are first taking exactly the midpoint of a and b. Let it be c, which is equal to a plus b by 2. This is the bisection method. So now we'll find the value of c. If f of c is less than 0, we'll compare with the opposite signs f of a and f of c are of opposite signs. Then the next approximation root lies in between a and c. Root lies in between a and c. So let it be x1. Then the next root lies in between x1 and a and x1, that is x2. And x2 is equal to a plus x1 by 2. So continuing this process, if x2 is maybe positive or negative, if it is positive, since f of a is positive, f of x2 is positive, so the root lies in between a and x2. Since f of x2 and f of c are of opposite signs, the root lies in between x2 and x1. And the next root is lies in between x2 and x1. Let it be x3. It is x1 plus x2. So continuing this process, we will reach an approximation value. If it is not in the case, that means if f of c is positive and f of a is positive, f of c is positive, then the root doesn't lies in between a and x1. The root lies in between x1 and b. If f of c is greater than 0, f of b is less than 0. Since the root lies in between x1 and b, x2 is equal to x1 plus b by 2. And we will calculate f of x2. It may be positive or negative. If it is less than 0, since f of c is positive and f of x2 is negative, the root lies in between x2 and x2, not in between x2 and x. So continuing this process, find the root of the approximation root of the equation.